You must specify a return type for each function. If the function is not returning anything, void is used as the return type in the function declaration. Unless specified, arguments that are passed to a function are passed by value. The programmer can specify that the parameter should be passed by reference. When returning a pointer, make sure the pointer was declared outside of the function. A pointer variable declared within the function will be placed on the stack. The scope of a local variable is from declaration to function end. Something else to be cautious of is when passing pointers to arrays as parameters. Calling the sizeof operator on the array pointer prior to function call will provide you with the correct size of the array. However, if attempting to use the sizeof operator on a parameter, the sizeof operator will display the size of the pointer variable, not the array. Make sure to pass another argument to the function that contains the size of the array if you need that information. If you're passing a pointer argument to a function and you don't want it to be accidentally modified, include the keyword const before the pointer's data type. Once in a blue moon, you'll write some code that's mutually recursive. For example, function 1 calls function 2 and function 2 calls function 1. In this case, there's really no way to arrange the functions so that the C compiler will be happy. You have to declare the functions prior to calling those functions. Even better than placing the declarations called prototypes in C in the same document would be to place them in a header file. Function declarations are necessary since C doesn't allow forward referencing of functions. They're needed for static type checking. When including your custom header file, make sure to wrap it in double quotes to tell the compiler that it's a local file, search via relative path, and not in a directory where a library code is located. You can place the full path name in your include statement if you're including a header file with double quotes. After the compiler finishes pre-processing the code, the header file code will be copied to the point where the hashtag include is specified. The compiler doesn't actually create a new file, instead it pipes the information through the compilation process. If you're including a header file whose definitions are located in another source file, you'll have to specify both source files when compiling. For example, gcc file a.c, file b.c-o file a. If your function is returning an int value, even if you don't declare a function prior to it being used, the compiler will still compile the code correctly. When the compiler gets to that portion of the code, it'll assume the function returns an int since that's the majority of the function returns. C supports variadic functions, which are functions that accept a variable number of parameters. To create your own variadic function, you'll first have to include the standard arg.h header. When defining a function, you'll have to specify that the function will be a variadic function by including the ... ellipses after the parameters of the function. Within the function, you'll need to create a va_list or variable argument list that will store the extra arguments that are passed to the function. After you create the va_list, you'll also have to specify the last fixed argument with va_start macro. Va start accepts two parameters, the va list and the last fixed argument of the function. To finally read the argument, you'll use the va args macro. Va args accepts two parameters, the va list and the type of the argument passed to the function. Once you're finished reading the list of arguments, you'll need to tell C that you're done with the va end macro. Va end accepts one parameter, the va list. To create a variadic function, you'll need to have at least one fixed parameter. Function names are pointers to the function. The pointer variable contains the address of the function. If you have a function drive, then drive and symbol drive are both pointers to the function. The function pointer name is a constant. To create a pointer variable that points to the function name, you'll have to specify the return type of the function, the name of the pointer variable wrapped in parentheses, and the parameter types that the function that you're pointing to has. This is normally done when you're passing a function as an argument to another function, or if you're creating an array of function pointers. Certain object-oriented languages that are built with C utilize function pointers to create many object-oriented features.